The next session is going to be, I think, kind of interesting because we have Prashant here who's from Carrier, and he's going to talk about some kind of tool. I think many of you might have heard the tool. It's HAP. That's not what makes it interesting. Of course, having a simulation or performance tool is interesting, but the reason this session is interesting is because Carrier is in the business of selling HVAC equipment. And normally, they try to sell more and more equipment of larger and larger sizes. But here's somebody who's going to tell you how to not order the largest equipment, how to downsize, right-size the equipment, and what kind of tools you can use. So it's the first time, at least in my experience, when an HVAC equipment manufacturer is telling you how to buy less. And that makes this a really interesting session. Yeah, thanks.
Thank you. So good evening. Energy drained. I've got only 150 slides, so you'll have to just bear with me. So, I'm not going to do this presentation one way, frankly. This is not the objective of my session. We would definitely have some participation and interaction. So I've got the first question to start with. What is the one key takeaway which you had from the previous sessions? What is that you will do to achieve or step towards the sustainability goal? What is that one thing you would do? Key thing. Anybody? We've had 1.5 hour session, right? Just about. Anybody? If at all you are an architect of a building and you are trying to do something to achieve sustainability or inch towards that, what is that one thing you will do? What comes to your mind first? Passive design, yeah? What else? Louder, please. Appliances you choose, okay? What next? Minimize the requirement. I think that's a fantastic answer. So basically, reduce the demand, right? Reduce the demand in terms of electricity. Well, that is what we're going to talk about today. Our buildings today are like this, right? So disparate systems, like each system working in its own zone, not talking to something else. We have carbon emitters, which means that, either these equipments were bought about 10 years back or 15 years back, may be efficient, may not be efficient. They could have been efficient at that point in time, but may not be now compared to today's standards. Of course, unprotected. When I say unprotected, like COVID situation, we were scared to get into office, right? So then, of course, not connected to the outside world, BMS connectivity and things like that. So we've been discussing about this. There's a study which quotes 90% of our time we spend indoor. Okay? If somebody from Delhi here, so we all complain that, pollution, outside climate is bad and all that, but our indoor climate is equally bad. So this is backed by data, a study conducted by Harvard University. So 90% of the time we spend indoor. And indoor air can be 3 to 5 times more polluted than the outside air. Okay? And in the next thing, buildings, any buildings, that accounts for close to about 40%. You've been hearing these numbers for quite some time now. And 1 in 5 buildings needs to go through retrofitting to achieve those sustainability goals. So what is that expected out of you, the buildings of tomorrow? They definitely need to be healthy. Of course, we want to go to office and come back, without any sick, syndromes. They have to be sustainable, no doubt. That's a basic thing. And it has to be intelligent as well, along with being safe. Now, this is a chart probably you've been seeing again, third day today. So I'm not going to elaborate on that. But there are some key takeaways. First and foremost, we need to design something which has the lowest demand. Connected load has to come down. But we've been talking about that. How do you do that? Who is going to tell you that this is the correct size or this is not the correct size? Okay. Then energy efficiency design during the operations. We've talked about energy performance indexes. So all these initiatives are good. But what is that I can do? In the net zero journey, you have 2 things. Somebody just touched upon passive and active. Under passive, orientation and envelope are the 2 things wherein you can make an impact. We will see in the upcoming slides how do we do that. Under the active, where is energy efficiency, there you can get into that table somebody mentioned that I'll select more efficient machines and things like that. All right? Now, have you seen this chart or this type of chart earlier? This is something known as, one, on the x-axis, you have energy consumption, low to higher. And on the y-axis, you will see that usage variability versus design. This is the biggest challenge what we face today. So when we are designing any systems, the availability of the information is very limited at the initial stage. So you take quite a lot of assumptions, right? And you design. However, good amount of research goes into that to design systems like lifts and other equipments to a greater degree. They don't consume much also, hence they fall in this quarter. But the more you move towards the right-hand side, so you have lighting, right? And then the major chunk is coming from HVAC, okay? So what makes it? It is close to about 40 to 45%, right? Based on the zone, climatic, multiple things, but it is about 40 to 45%. And out of that, chiller is about 65% of energy consumption in any plant. That is why people put a lot of efforts and emphasis on buying an efficient chiller and things like that, and followed by pumps and cooling towers and other energies anyways. Well, what makes this more challenging for a designers is occupancy. Can you tell what is the room size, this one? How many participants can sit in this room? 100, 150? Okay, how many of us we are sitting currently today? Maybe about 100 or 80? So when it is designed for full capacity. Has it run full capacity always? This is due to the variance in occupancy. What is the weather like? You are in a November, Goa is comfortable. Come here in other months. You will hate Goa. Okay, so I mean, that is about weather. So all these parameters impact the building design, right? So now, I'm from Bangalore. So in Bangalore, whenever somebody is designing the chiller, what is the temperature? Anybody from Bangalore here? What is the peak Bangalore has seen? Oh, without referring to the graph, of course. What is the peak temperature? Any number? 30, 32, 35 degrees centigrades? In fact, we have touched 37.2, right? So-called one of the coolest, but we have touched 37.2. But look at this. More often, the temperatures are in the range of 20 to 28. That's the band. That is where chillers are likely to operate. That's where your plants are likely to operate. So should I have to design it for 37, 38, which runs for just about few hours in a year, or should I be designing for this? What one should do? 31, why? What will happen when the peak design happens? You will get complaints, right? Not getting cooling, right? So those are the challenges. So now, you have to figure out where do you fit into this graph or this chart. Are you a user or a customer? Are you an architect, a MEP designer? Are you a green building consultant? Are you a project management consultant? A MEP contractor who actually executes the job? Or a building and developer? Sometimes, you have heard about this. I build my building, I am not bothered about how it's going to operate, and I'm going to lease it out. Or, it's my building, my baby, I'm going to own it and, So, you have different stakes. I'm not going to touch upon each. Everybody has got their own interests, right? So, this is what actually is making a big disconnect in the industry today, right? I mean, of course, I'll take the liberty that this forum is more of architects. We come across quite a lot of architects who don't want to change their design, no matter what. This is my design, I'm not going to change it. Okay? You have to deal with it. But there are HVAC consultants who will say, this is my design. I've been designing my system for the last 20, 25 years. I'm not going to change anything. So with these kinds of people, how are you going to drive sustainability? Okay? Very difficult. Okay? Now, under this gamut, we're going to touch upon sustainable cooling and definitely low carbon environment are the two key parameters. So we talked about it. For a building to get heat or heat loads, what are the parameters? There are three key criteria. One is, of course, the external things which none of us have a control on. Your weather can go haywire. Take an example of Delhi. It can be, chilling. It can be equally hot. So you need to design system which works for both. The kind of glass you use, the kind of insulations which are used, shading coefficients, your transmission, infiltration, all this will have an impact on the total cooling loads. At the same time, internal activity level. Now you are all sitting quite calm, okay, no activity. But think that if this room converts into a gym, then what would happen? A lot of, heat load would come into picture. So that's why heat gain from people will come into picture, a sensible and the latent and the total heat and all that. The type of bulbs we are using, of course, on the stage we are using quite a lot of, heavy lux, but ultimately we talked about 100 lux is good enough for regular work. So that matters, connected load matters. And then also there are system-related leakages. You have experienced it. If you have your apartment on the top floor, you will obviously feel the heat coming from the top, from all the corners. If you're in the, let's say, lower floors, you don't feel that. Same is the case with buildings, right? Well, if you are an HVAC engineer or coming from that particular background, you need to do quite a lot of things. Earlier, we were doing all these things manually. Architects used to give a drawing, sit with that drawing, mark that, take one particular room, do the design, tabulate in an Excel, then work out, which was more to do with the instantaneous loads, because you have no idea about how the weather profile going to be. It was more to do with instantaneous for the peak. But today, we have sophisticated tools available. As we move on the complexity curve, you are also moving up on the accuracy curve. More the complex calculation, more is the accuracy. So there's something called as somebody from HVAC background or mechanical refrigeration background can understand, heat balance and things like that. So heat balance is considered to be one of the best in terms of heat load calculations. So now, you have heard about safety factors? Structural engineers here? Anybody from structural background? Or even in architecture, you must have been taught, right? You need to have some safety factors, design buffers and all that. It happens even in HVAC. All these safety factors are because of various reasons. Your window to wall ratio may be clear, may not be clear. Your lighting area, occupancy data, all these factors actually add to the safety factors. And when we actually notice it, I add just 5% here, I add just another 5% here, can result into something like 28%. What we are doing? We are basically oversizing at every level, at every step, which is leading to the next question: how do I address these variables? They are not under my control. How do I control weather? How do I control occupancy? That's when the answer comes here. So there's a tool known as HAP. Any hands rise here who has heard about HAP, Hourly Analysis Program? Okay, good. One hand, two hand. Okay. So Hourly Analysis Program is nothing but a one heat estimation program. At the same time, it's also a simulation program, which means that you can calculate the total heat load required. When I say heat load, which means the plant load, how much tonnage I have to put in this building, but at the same time, how that's going to be behaving throughout the cycle of its operation. So it can give you energy reports, because you want to compare buildings A versus building B or building A versus the baselines. It can give you simulation reports. It can give you opportunity to experiment with various types of equipments. So for a typical hotel, around 200 or 300 tons, what should I buy? Should I have to go with the chiller kind of systems, or should I have to go with the VRF kind of systems, or I just go ahead and put 10 splits at different places? So this can answer you what is better for you. Well, when you are talking about larger plants, then certainly you get into more and more detailing with respect to equipments. So it's just not only a load calculation tool, it's also a system design tool, energy modeling tool, then reports in any fashion. Today, everybody likes graph. Nobody is interested to go through the Excel table and try to understand that. Everybody loves graph and try and understand. Whenever we meet customers, when we ask, sir, what you need for a sustainable building, they say that I want efficient chiller. Nobody want to touch upon what is going into the design, or their interest is not that much there. So we are here to educate them on that. This tool has got certain fantastic features. This is what I actually wanted to impress upon. This has got around 7,400 cities covered. You can think of almost any city in India, the weather profile is available, which means that you can do a project in Tier 1, Tier 2 cities, and you can do the simulation. Unfortunately, a lot of data is not available from the market. Even if the data is available from the market, from the weather stations, it is not authenticated. The data which it has is from the authenticated. This program is approved by DOE, Department of Energy, by US. At the same time, LEED, US Green Building Council, and ASHRAE also has approved it. Hence, the authenticity on data is to a greater extent. You can take that data, and maybe if you think that by the way, I have this data, but I want to design slightly with my buffer. It gives you an opportunity to do the changes as well, right? And these tables will help you to make those changes. The best feature is you can even put the outside CO2 levels. A lot of air conditioning design wherein we take the outside air. What is that called as? Fresh air, right? So it is not fresh air anymore, okay? It is an outside air, you filter it and take it into that, okay? Because you want to ensure the inside CO2 levels are maintained. So you need to know what is the outside CO2 level as well, right? So hence, this is just a 400 is not a standard number. You can actually take this data from outside and key in that. And then you can decide, is it making sense for me to taking outside air or I rather circulate my inside air, right? And it also gives you opportunity in terms of going to the next level of how many hours I should be doing. Is my building 24/7 like hospital, or is my building just 12 hours? You can do all that, things. Coming to building modeling. Assume that you are working on a detailed architectural drawing, then you can get into more and more detailing like this. First, you can also take, this tool is so, easy. You can even take a picture and just, you can upload that and start drawing on that, which is known as sketch over. I will just take that picture and start sketching over. I can start making my zones, right? I want to have a partition here, you can do that. Then, it will also create a 3D model for you. The way how you started doing the bifurcations or putting a wall, putting a window, all that you can edit. And this will give you a 3D modeling like this. And then, in case if you feel that thickness of the wall needs to be this, you can go ahead and edit. I want to increase my wall to window ratio, you can go ahead and do that. I want to put a canopy there, choice is yours. Glass tinted, go ahead put that. With every change, there is a change in the U value. You understand that, right? With the change, there is a change in the total heat loads. So you can do all that. Now, after all this, you're going to get a 3D model ready for you. Now that becomes your base model, which means basic minimum requirements. Over and above that, you can put another model which is something to do with the challenger, right? In case if I make these changes, I want to take my building to the next level, what is it, right? So all those things can be done. So how intuitive it is? One, of course, wizards, wherein we saw the weather. I'm now showing you with the building. Think that you are doing a design wherein not much of a data is available with you. Initial days of designs, wherein somebody told you that I'm coming with, let's say, 1 lakh square feet, and tell me what is the heat load. You will ask which city. So certainly you have the weather data, you can pull that data. Next question you can ask is, what is the type of application, right? Based on only these information, you can basically do the design. This gives you a library with 5 or 6 types of building, rectangular, square, T-shape, U-shape, L-shape. You have the design available there. You have the number of floors. All that is key in, right? Then you can also put your other criterias, which means, is it an office building? Is it a hospital? Is it an infra? All that is a drop-down. This is a feature which is helpful for you in the initial stage of design. You can't say that I will turn around your design in 15 days or 1 month. Nobody will have that kind of a time. You need to turn around much faster. So this will help you in giving you that quick estimates. And then once you arrive at that, you can also do the high level in terms of, how much capacity, what should I do, how many chillers I should put. This is at an initial stage, high level. Oh, sorry. So now, for example, here, okay. Yeah, you have done one base building, and then there is a proposed building. Architects has told that this is how the building is going to look like. I'll not allow you to change anything. So now what is left with you? You can probably play with other things. Think that 0.82 watts per square feet lighting versus 0.4. You want to see the change. If I do only change with the lighting, what is that it's going to be? So you can certainly, get that simulation reports done. Okay. Now, this tool is also equipped with integration with Energy Plus. How many of you have heard about Energy Plus? Good number of people. It's a good energy simulation tool. So this program is also coordinating and taking certain features from Energy Plus, and certainly Energy Plus is from DOE, Department of Energy. And now we have taken quite a few detailing from there. So those detailings are mostly with respect to the shading. Earlier this was not there. Now this feature is pretty much there. You know that building has its own property of shading by itself. that can be simulated. Most interestingly, you can now do the daylight simulation. Earlier, an architect has to go to a HVAC consultant to get the heat load, and then to a lighting consultant probably to get this daylighting and other things, and they have to marry both. Now it's not required. You can do them together to get the coordinated or what you call as integrated outputs. Likewise, you can basically demonstrate without daylighting what it was, with daylighting what it was. And of course, this is one more fantastic feature with this, which is known as scheduling. Scheduling is nothing but, even in the office, how much of time I'm going to spend in my conference room, or how much of time I'm going to spend on my own desk. What are the kind of activity I do? So you can program this. You can actually schedule holidays. You can schedule your work timings. Nowadays you are all hybrid work and all that. So you can do all this programming and just pull this scheduling into your assignment. Assignment as in which room you are looking at and things like that. It gives you results accordingly. This is one of the greatest feature which is helping you to eliminate those kinds of safety factors. Reports. You can pull weather reports of any sorts. You can pull system design reports. What have you done? What are the changes? This gives you of course, I've just shown just a couple of reports here. It can be in tabular column or, any type of graphs. Multiple options are available, And then energy analysis reports also. So this is the capability of this tool. But what is that it is helping in the way of sustainable journey? Okay? Look at it. As a tool by itself, you can turn around high level of estimates very quickly, which means that it is increasing your productivity. And it also helps you in detailed designing. When you get a detailed drawing, it helps you to do the detailed designing. Then feasibility study and option exploration. Just an example, if somebody is willing to invest, let's say, certain crores, and he comes and asks you, is it making sense to invest in, say, a city in Delhi versus a city in, say, Jaipur? At both the places, he has got land, taking the land parcel aside. He has want to build the building. So he's going to ask you that, what is that my 15 years or 20 years life cycle? They will understand ROI is better. You can do that kind of analysis here, life cycle cost analysis kind of things, because you can simulate the building with Jaipur data, you can simulate the building with your Delhi data, and then churn out the complete reports on that. So then you can also do the sustainability goal setting. You can understand air-cooled chiller versus water-cooled chiller? Any basic idea? Okay? No? Yes? Okay, so water-cooled chiller runs on water. It requires water for its condenser side. Unless until you have the water which is available at your premise, it becomes an expensive affair. You need to buy the water from outside. There are quite a lot of buildings today who had installed the water-cooled chillers, but had to keep it shut because of the availability of the water. Sometimes water is available, but the quality of water is not good. It's not usable. Or they might have to spend good amount of water to treat that. So those kinds of times, you can do the feasibility. Okay? So that is where HAP can help you to do that initial studies and recommend what is good for that particular Now also, you'll be surprised. Don't use sophisticated tools for whatever reasons.